Okay, here we are talking about a corollary to the side splitter theorem. A corollary is just an extension of that side splitter theory, which we looked at over here where we got this top to bottom ratio, okay? So, this says we start out with three lines that are parallel. Now, any way in which I move these, okay, the parallel nature still remains, okay? And what I'm going to do is I'm going to take these three parallel lines and I'm going to cut them by two transversals, okay? So here we are cutting them by two transversals. So now what I want to do is I want to mark these points of intersection with the transversals, okay? So I select my transversals and let's mark off the points of intersection, okay? Construct the intersection, then what I want to do is construct this intersection. And here's my intersection down here. And now, okay, construct my intersection this way. And construct this intersection. Okay, so that way, no matter how I move these things, okay, I'm maintaining the intersections, okay? Now let's just label these points, okay? A, B, C, D, E, F. And what it's going to say, what we're going to find here, is that we're still going to get this top to bottom ratio between these segments. So in other words, AB is going to be to BC as DE is to EF. So we got the top to bottom ratio, top to bottom ratio. So let's just quickly make those calculations, okay? AB, measure the distance, AB, measure the distance, BC, okay? And we'll take their ratio. And so now we can take the ratio. Number, calculate this value divided by the bottom, top to the bottom, okay? And that's 118. Of course, that's subject to change as we move this around, okay? But what we're going to see is we're going to see over here that DE to EF is going to be the same thing. So let's make those measurements, and then that should demonstrate this side splitter corollary, which is what we have when we have three parallel lines cut by two transversals, okay? So again, let's measure here, okay? Measuring distance there, 3,7, okay? And the distance E to F. And now we take their ratio, okay? And so number, calculate the top piece to the bottom piece, okay? And what we should see is, of course, that is in the same ratio as the others. So again, okay, when three parallel lines are cut by two transversal, those sections of the transversal define the top and bottom portions. AB to BC is the DE to EF. So we get the top to bottom ratio is consistent, okay, from the left and the right side here, okay? No matter how I manipulate this thing, you can see these ratios are remaining the same. So again, much like the side splitter, we get the parallel dividing it into a top and bottom section, and we get the ratio of top to bottom on both sides is consistent. Just as with the side splitter corollary, we get the top and bottom pieces, okay, of the transversal, if you will, and the top and bottom ratios are going to be consistent, okay, all the way through, okay, and that's your side splitter corollary.